We've just given you the formulas for sums and differences of sine and cosine, and now we want to practice using those formulas with some actual practical problems. A comment: what would happen if I ask you to find the tangent of the sum or difference of an angle? Do you have to look up a different formula? No. You just take the sine formula and divide it by the cosine formula. And that's the way I prefer to do it, because I never memorized the tangent formula. Okay. So let's not do any of those yet, and we could do the reciprocal ones as well if we chose to. But let's just practice using some things from our unit circle. So let's see, if we took some familiar angles like say 30 degrees and 45 degrees, why don't we use, let's use 30 and 45, okay? Let's find the exact value of, let's start with the sine of 75 degrees. The exact value is 75 degrees. Fun, okay? First of all, think. Always think of what kind of result you might expect if it's relatively simple for you to think about it. On your unit circle, if you're at 75 degrees, you're clear up here. And you know at 60 degrees, your sine is what? What? Okay. Square root of 3 over 2. Square root of 2 over 2 is too short. That's at 45. Square root of 2 over 2. Square root of 3 over 2 is your sine of 60 degrees. Right? So and that's about 0.866. The answer we're expecting here better be bigger than 0.866 when we get done. But again, we're looking for the exact value, aren't we? So our answer, sine of 75 degrees, better be bigger than 0.866. And we can check it with our calculator when we get to our exact value. So we start by thinking what?
What plus 75?
30 plus 45, right? Okay, making this pretty easy. 30 plus 45, right? Now you have to change this structure. Here's the classic mistake students make in trig. What do you think they write down then as the next step?
Sine 30 plus sine 45.
Yeah, they'll write down. Don't do that. I shouldn't even say it out loud. It's not sine 30 plus sine 45. No way. We've got a whole new angle, 75 degrees sitting here. Whole new angle, and we're looking for the trig ratio of that angle. So we have to use that formula. You start on, when you have your sine formula, you start with your product of sine and cosine. And you add to that the opposite combination, the cosine of the first times the sine of the second. Each of these items here underlined are ratios, aren't they? Each of these results here are ratios. If you're automatic on your unit circle, which I'm hoping you are, this is 1/2 ratio. This is square root of 2 over 2 ratio, plus cosine of 30, mentally image it, square root of 3 over 2 ratio, and finally sine of 45, square root of 2 over 2. At this point, you should be getting almost as quick as me on that. Now you tidy this up, and we see a square root of 2 plus square root of 6 over a common what? 4. There's an exact answer. If you open up to the back of a book on a problem like this, you might see the answer in a slightly different form. What you might see in a book is, observe up here that there's a common square root of 2 in each of these terms. You might see that factored out, and you might see the 4 factored out as a common denominator. You might see this answer written as square root of 2 over 4 times the quantity 1 plus square root of 3, or a variation on that. Okay? It's that easy. Now, if you punch this on your calculator, why didn't somebody quickly punch that for me? This is the exact answer that we're looking for. And we better get an answer bigger than 0.866. Anybody have their calculator sitting out? And while somebody's punching that to get me a value to 4 decimal places, I'm going to write another problem up here. I want you to try this. Let's try cosine of, how about 150 and 45, 195. Cosine of 195 degrees. And what'd you get for an answer here with the calculator?
0.866.
Better.
0.965.
0.9, 0.965 approximately. Okay. Can't be 0.866, that's at 60 degrees.
I see what I did.
Ah,
It was
yes.
divide instead of added.
And also, when you're going to punch this on your calculator, folks, you better put a parentheses on that numerator. Okay? Otherwise, you'll get a bogus answer, and that's why if you get a wrong answer, you ought to think first before you ever start this thing of what kind of answer to expect. That's the primary value of that 16 angles and their trig ratios, and you knowing those. Okay. Got a few minutes left. Let's do this guy. I would not want to think of it, if I want an exact value here, I would not want to think 180 plus 15, right? If I'm looking for an exact result. So what might you think to break this up into angles that are pairs of our 16 angles? Think for just a second. I'm going to close the door here. Stand outside and talk. Okay. Any idea?
150 and 45.
150, 150 and 45, okay? So we can think of the cosine of 150 degrees plus 45 degrees. Or could I think of, see, how about 240 minus, what's no, how about 225 minus 30? Is that right?
Yeah.
225 minus 30? Is that 195? Yeah, right? Both, either way, right? So how about the front 2 rows do this problem, and the back 2 rows of the class do this problem, and we'll have a race, and I'll do it, I'll do both of them, and see who wins. Okay? Folks in the front 2 rows do this problem, folks in the back 2 rows do this problem. Yes?
You said at the start of class we should just work slow and steady.
Oh, slow and steady.
That's true.
Okay, I want you to okay. Work slow and steady but fast, okay? Okay. Done. So you should be getting an answer more negative than minus square root of 3 over 2, I believe. And I believe we might be ending up with the same value we got previously except negative. Negative 0.965. Either way, thinking of the angle as the sum of 150 and 45 degrees, and then use the law of cosine sum formula. And notice the plus and minus signs change here, and they start with products of cosine and products followed by products of sine. Similarly down below, when you have the difference of the angles, they become a positive between the terms, and you are automatic, or getting automatic on your unit circle skills, and so the exact answers turn out to be identical here. And you always think your way into, did you punch it right? Because you can always go back and draw a little sketch like I've shown you here and make a prediction based on the 16 angles that we've studied earlier. Pretty fun, huh? Okay, two simple formulas. Any questions, Tom?
I think I missed the formula, the plus and minus, or the signs are opposite of each other? I thought they were the same.
Correct. Come back over with the camera. There we go. On the sine formula, the plus and minus character, if you add the angles, there stays addition here.
Okay.
If you take the difference of the angles, it becomes a difference.
Cosine there.
Cosine, they reverse on the plus and minus character. Very important. Some trig instructors will let students have a formula sheet like I gave you earlier in the term to use throughout the course. But I think I personally think that you should memorize certain ones. There's some more complicated ones we haven't gotten to yet that you don't need to memorize because you don't use them very often. You can just look them up when you need them. But these are really important, and we're going to use these in the next session to do something dealing with what we call double angles. And so there's some other formulas, but they tie back to these. So that'll end it for today. Practice these things over the weekend, and you should be in good shape by early next week.